go. Hi. It's exam 3 time. Exam 3 review time. So, chapter 4. However, chapter 3 is what you are going to see a lot, obviously, because chapter 3 is the ways to take the derivative, and chapter 4 is to apply it. So, since you will be taking derivative in every problem, then you are technically doing chapter 3 every time you do anything with chapter 4. So, as I go down to list, I'm not listing chapter 3 concepts. Just know that as you're taking derivative for all of this, you're using chapter 3. Number 1, min-max. So problem on min-max, you need to know, take the derivative, set it equal to 0, or see if the function, the derivative doesn't exist at a point. And you will find min and max. Number 2, first derivative test, second derivative test. This is what we have for first derivative test, second derivative test is what we have. 2 problems, right? One for one and one for the other. They are not related, so please don't, continue. If it's asked for a second derivative test, just you take the first derivative and then you take the second derivative and you do the test. I have students do the full first derivative test for no reason within that problem. If I'm asking only for a second derivative test, take the first derivative, take the second derivative, and then just do the test. So first derivative test, 2 problems. Yes. Number 3, graphing. I will give you everything. So, guys, everything that you need to graph a function will be provided. You just need to draw the graph. You don't have to calculate a single thing. So, I am giving you x and y intercepts. I am giving you the increase, decrease. I am giving you concavity, essential oils, world peace, everything on a pile. And you just need to draw the graph. Right? Everything is present. You just draw the graph. Number 4, linearization. Equal tangent line. This is a half of one of the lectures. Number 5, mean value theorem. Definition plus calculation for C. If you remember, you were supposed to calculate the value C at which the average equals the instantaneous. So that was that. And I think this is what ends, oh no, L'Hopital rule. Zero over zero, infinity over infinity, 0 times infinity, infinity minus infinity, and what do we have? 0 to infinity, 0 to 0, 1 to infinity. So these are the cases. L'Hopital rule. 7, anti-derivatives. I'll just put basic integration. Your definite integrals with limits and calculating, they're not part of this. That's 5-2, right? So they're not part of this. These are basic integrals, and here in blood plus C or -1. Now we are getting into the word problem area. Okay, so I tend to repeat, not always the case, but I tend to repeat related rates 311. You have optimization, which is, I think, was 4.5, I think. Differentials. Instead of guessing, let me just take a look at the book. Optimization 4.5, differentials 4.6. So these are your word problems, and then the mean value theorem also has word problems, but you're getting one or the other, not both. That was 4.2, I think. Yes. So this or that. So you're not going to have two mean value problems. So it's either going to be a vanilla problem where you get to calculate C and you are done, or it's going to be a word problem where so minimum number of word problems is 2, maximum number of word problems is 3. So 2 or 3 word problems. And as you can see, 311 is listed as well, related rates. So take a look at that. That was there on a previous exam, and it didn't go well. So some of these sections that are the most important sections of Calculus 1, such as chain rule, optimization, use sub later on, they have to be pushed because you will use those a lot later. I mean, if this is your terminal course, then you're done, terminated, right? But if you're taking Calc 2, and then if you're going to be engineer, obviously, which everything is a word problem, it goes like this. Go construct a bridge. That's your word problem. So now you have to go and make a bridge. Or get me a new version of the car or something like that. That's all word problems. Linearization will be again learned in Calc 2 in a more powerful way, but for linearization you can either use the tangent line or you can use the linearization formula. If you remember linearization formula at all, it was, so linearization was L of x equals f of x plus f prime of a x minus a, right? Or you can use tangent line, or use tangent line. What you need to know is that linearization is calculating the value, approximating the value of the thing that you don't want to compute. So let's say you are supposed to compute ln of 9.6. Well, ln of 9.6 is something that it's very close to ln of e squared. So you would use e squared to find your linearization or to find your tangent line. And then when you have the line, from linearization or the tangent line, you will calculate 9.6 in the tangent line rather than in the original ln function. So that's why we do linearization, to make it easier. And always today is obsolete. You pick up the calculator and before even the derivative dropped for the other one, you already have the answer. But as I said, solar flare, we talked about it, right? Resets us back to Stone Age, and now you have to, rebuild everything. So what is ln of 9.6, right? So you get to enjoy that. Optimization word problems. You are looking into the farmer problem. You're looking into all of these problems that are done in class. Geometry problems of minimum surface area, maximum volume. Farmer was maximizing area with the constraint of the perimeter. So something that it's, doable, so we're not sleeping here in terms of how much extra time you need to solve the problem. Min-max problem, you set the derivative equal to 0, you find critical points, you go from there. First and second derivative tests I talked about. Make sure you are, for those first and second derivative tests, write this down. Make sure you are writing your answer as intervals of increase, decrease, concave up, concave down. That's the answer of these things, right? So it's not just you go through the procedure and you do the partitioning, you put those arrows and you leave. You actually have to spell it out. On interval so and so, we have decrease. If you have multiple intervals, you use the union to link them all. You always use parentheses, right? You don't use the square brackets. You always use parentheses because the difference between the parenthesis and a square bracket is that end point. Can function be continuous? Can function be increasing at one point? No, because you need 2 points to see which one is higher. So you don't get to say, oh, it's increasing at 3 as the end of the interval, right? So make sure you have the interval given and you use parentheses for that. So that's the first, second derivative. First derivative will also give you min-max for free, right? Well, second one does too. And then graphing, I already said, I'll give you everything. You just need to draw the line, so practice some of those. And I think L'Hopital rule we covered today in detail. You have 5,000 examples. So generally for exams, it's either a vanilla case, be careful with derivatives, or 0 times infinity, or one of the, right? Like infinity minus infinity is rare. I mean, it's not impossible, but it just takes forever and we don't have time. So, yeah. But the ones with the exponent, when you go the ln, those could also be long, but those are also very important. They show up in your Calc 2 class, all right? So 0 times infinity and infinity minus infinity, they are not as frequent in your Calc 2 class. But the basic L'Hopital and the exponential ones, yeah. I actually had on Tuesday or Thursday, we were doing something, it popped up, and then it was funny in class, right? Because of certain comments made, not by me. Shockingly, right? So that's the exam. About hour 20, hour 25. And after that, we will finish the 3 sections that we have for our chapter 5. 2 of those 3 are extremely short. It's probably going to be like 15, 20 minutes each at most. And then 5-5 will take a very long stretch of time, because without that one, do yourself a favor and never sign up for Calc 2. Okay, if you don't know 5-5, it's just don't. Because 90% of integration in chapters 6, 7, 8, and 9 are going to be U sub, right? So 90% of them. So we need to know that. Review session for the final, scheduled for Tuesday. I don't have the time yet. It could be most likely at 5:30 on Tuesday. 5:30 on Tuesday. I'm trying to keep it in the afternoon because some of you might have 9 to 5, right, jobs. So possibly 5:30 to 7:30. And I can't see you prior to that because I also have algebra review. So I go to algebra review first, then I go for your calculus review. So that's the Tuesday reading day in what? 9 days from today, 10 days from today? And then the final is the following on 11th. Did we decide the time for the final? What time do you want it? Like 10? 10 a.m.? Everyone good at 10 a.m.? All right. So the final is then going to be 10 to 12 on Saturday, 11th. Okay. Any questions, concerns, concepts, problems, anything for exam 1 for me to work out if you need to see? Going once. Going twice. And sold. All right. I'll see you all next week.